Standard EMF of a cell is the difference of the electrode potentials of cathode and anode. So cathode should be higher and anode should be lower, so that you get the positive difference. Then only the current will flow from cathode to anode. Clear? EMF is greater than 0. If what will happen if EMF is less than 0? Can some of you tell me what will happen if EMF is negative? Is the cell going to work? What do you feel? It is just like your, yeah, tell me.
It will damage the cells or the battery.
Yeah, it will not work. That reaction will not be spontaneous. Got it? Such reaction in the initially when we have started this chapter, we were discussing that there were spontaneous reactions and non-spontaneous reactions. Spontaneous reactions can happen on their own. They do not need any external help. Non-spontaneous reaction need to be pushed. Okay, so if the EMF is negative, if E cathode is smaller than E anode, okay, such cell will not work. Or that cell will work only if you have to put electric current in it. You need to, electrical energy will be consumed. Okay, these are non-spontaneous reactions. Is it clear? Ibrahim, I hope it is clear. Just clear.
Yes, sir. Yes.
Aisha, Marwa, is it clear?
Yes, sir.
Now we got stuck at one point. That was how to get the individual electrode potential. Until and unless the current flows through the two electrode, until and unless the current flows, we can't measure the electrode potential. And to flow the current, to make the current flow, you need two electrodes. And two electrodes will actually, they will affect each other tendency to give and take electrons. And our problem is that we want to get the electrode potential, absolute value of electrode potential of a single electron, like cathode, anode. If we get this value and if we get this value, we will take the difference and we can find out the EMF of the cell. Right? But an EMF, yeah. Tell me.
Can you repeat?
Yeah. To calculate the EMF of the cell, you need electrode potential of the cathode and anode. Do you agree with it?
Yes.
EMF is the difference in voltage between the positive terminal and the negative terminal. For example, if you take a pencil cell, all of you have seen which we put in our remote and all, right? We use that. What is the difference? What is the EMF? Can any one of you tell me in the pencil cell? Which we use in our homes.
1.5, yeah, 1.5.
Yeah, exactly, 1.5 volt. Okay, that is the difference of the two electrodes, positive and the negative. Right, Aisha? Marwa, is it clear?
Yes, sir.
Yes. So now, Aisha, we need to calculate that what we need to know. We need to devise some method by which we can get the electrode potential of cathode. and anode. So how to measure them? That was the problem. Okay, is it clear? And as I told you, it is impossible to measure the electrode potential of each individual electrode. Why it is impossible to measure? Can any one of you explain it to me? Why it is impossible to measure the electrode potential of cathode or anode? Why can't we measure it? Because you need to connect. You can measure the difference between positive and negative terminal. But suppose if I ask you what is the voltage of the positive terminal, what is the voltage of the negative terminal, only you will not be able to measure with the voltmeter. Voltmeter when you put, or the wheatstone when you put, that gives you the difference. Okay. So it is impossible to measure the absolute value of electrode potential of a single electrode. Up to this point, is it clear to all of you? Jaslyn, Marwa, Aisha, Ibrahim, tell me, is it clear?
Yes.
You need to connect it to some, you need to let the current flow and connect it to some other electrode. You need to take the difference. You can measure the difference, but you can't measure the absolute value. Suppose if I give you, it is just like this problem. If I give you Aisha x minus y equal to 10, right? And if I ask you what is the value of x, what is the value of y? Will you be able to tell me? Is it possible to get the absolute value of x and y? We can't. We cannot tell. Right? Because this equation is just, it is same as EMF. EMF is the difference, right? And we can get the difference, but what is the actual value of the cathode and anode, we can't get. But we can get the difference. We need to measure the absolute value of x or of y. Clear? So now the problem has been sorted out by using reference electrode, and that is standard hydrogen electrode. Standard hydrogen electrode is taken to be the reference electrode for the measurement of electrode potentials of all other electrodes. So all other electrodes, so this is standard hydrogen electrode. and it can be connected to any electrode, and that will help us to measure the electrode potential of all the other electrodes. Got it? But now if it is helping us to measure the electrode potential of all the other electrode, what is the electrode potential of this electrode? This electrode potential is taken as 0. Electrode potential of standard hydrogen electrode sheet is and this is the reference electrode, Ibrahim. When it is connected to all the other electrode and its electrode potential is 0. Okay, so it is just like that you can get the value of x and y. Is it clear?
Yes,
If you
sir.
take y equal to 0, Ibrahim, right? So one electrode you need to fix. Otherwise, x minus y is 10, y can be anything, x can be anything. Okay, the difference is 10. They could be 100 or 110. They could be 210 and 200. It's a vicious circle. We can't get the value until unless we fix the value of one of the electrodes. So what is that reference electrode, Mara, which is used to compare the electrode potential of all the other electrodes? What is the reference, Ali? What is the reference electrode? That is standard hydrogen electrode. Is it clear? You need to remember this. The electrode potential is of all the rest of the electrodes is compared with respect to standard hydrogen electrode. Now the question is, what is the electrode potential of standard hydrogen electrode, Ibrahim? Tell me. What is the electrode
Zero.
potential of
Zero.
Yeah, 0. It is assumed to be 0. Okay. Is it clear? And so just keep this in mind. Okay. Very, very important. Now let's move to the construction of standard hydrogen electrode. So you need to draw it in a simple way like this. In your school examination, you need to draw it like this. This is a platinum wire. Sealed platinum wire. And it has a flat end, and it provides the surface for redox reaction, because you need electrodes, you need some surface of a metal where the platinum wire itself is inert. It is not itself getting oxidized. Platinum is inert metal just like gold. It is just providing a surface for the exchange of electrons. It is coated with platinum black or powdered platinum, which act as a catalyst. So, Aisha, what is the role of platinum wire in the standard hydrogen electrode? Can you tell me?
Sir, can you repeat?
What is the role of platinum electrode or wire in standard hydrogen electrode? What is the role of this platinum? It gives electron, it takes
catalyst?
electron. Yep, it provides the surface.
Hydrogen.
No, it provides the surface for transfer of electrons between the H plus ions and H2. Okay. There is a transfer of electrons. We need to have some metal. The metal itself should not participate. Is it clear? So it provides a
Yes.
surface for the exchange of electrons. This is platinum wire, and hydrogen gas is bubbled at 1 bar. You can see. Hydrogen gas is bubbled through the 1 molar HCl solution, 1 molar because it is a standard hydrogen electrode, so it should be 1 molar. Okay, 1 molar is the standard concentration at 298 calories. So 1 molar HCl means 1 molar H plus, and the hydrogen gas is bubbled. You can see the hydrogen gas is being bubbled through this HCl solution at 1 bar. And this platinum wire, this is the enlarged view of the platinum wire. So what can happen? The hydrogen gas can come into the solution and it can lose its electrons. Similarly, the H plus ions, two things can happen from the HCl solution. Can go on the platinum electron and they can accept the electrons. And change themselves to hydrogen gas. So you can see this is H2 molecule. It can collide with the platinum, lose its electron and change to H plus. And the H plus ions can accept the electrons. So both way it can happen. Is it clear? So this is the standard hydrogen electrode. It can accept electron in this manner. It can lose electron. Its electrode potential is taken to be 0 volt. Okay. It has hydrogen gas pass through HCl solution. Okay. Its electrode potential is assumed to be 0. It is chosen as a reference electrode to compare the electrode potential of all the other electrodes. So all the other electrodes are connected one by one to connected to standard hydrogen electrode, and their value, because standard hydrogen electrode itself is 0. So it will get the taking the difference. It can tell us what is the electrode potential of the other electrode. Let me give you an example. Suppose I am having a zinc electrode. So Marwa, this is zinc electrode and it is dipped in zinc sulfate solution. And if I ask you what is the potential of this electrode, how will you measure it? Who will tell me? Aisha, Marwa, tell me, how will you measure the potential or the electrode potential of this electrode? Aisha, am I audible?
Yes, sir.
Yeah, so what is the answer? Just in few words you can tell me. Suppose in the lab, if you are provided with zinc electrode, how will you measure experimentally? What is
I
the
will get
electrode?
the readings. So
By?
through the readings through the maybe the voltmeter.
Yeah, but voltmeter measure, yes. Voltmeter measure when there is a flow of current. If there is no flow of current, I have just given you one single electron. So you need to connect it to someone else to let the current flow, and you can measure the potential difference with the help of voltmeter. Is it clear? But what is that something else by which I need to connect this? What is that else? Something else. What is that other electron? Jasleen, what is that other
Like,
electron? Yeah,
will you connect it to the standard hydrogen electrode?
exactly. So what you will do, you will bring in the standard hydrogen electron. This whole setup is there. You will connect it, okay, to standard hydrogen electrode. Now there is a flow of current. You will measure the potential difference through voltmeter. Okay. So this standard hydrogen electrode, E0 cell, you can see the reading from here. Is it clear? And
Yes.
this value is assumed. What is the value of this? This is assumed to be 0. Got it? And this reading is 0.76 volt. Standard hydrogen electrode is assigned 0 volt. Its electrode potential is assigned to be 0. Otherwise, you can't calculate. If you need to consider one of the electrode as 0, and you will consider that as that electrode as the reference electrode, and you will connect all the rest of the electrode and compare with that reference electrode, and that reference electrode is 0. It is arbitrarily assigned. So what is the electrode potential of zinc electrode? Standard electrode potential. Marwa, can you tell me? Marwa, am I audible?
Yes, sir.
So what is the value? This is zinc. This is minus sign. The zero you remove. Minus you bring it on this side.
Minus 0.76.
Exactly. Is it clear? So, Jasleen, have you understood that how you are
Yes,
going
sir.
to use the standard electrode potential? How you are going to measure the standard electrode potential using standard hydrogen electrode? Is that clear?
Yes, sir.
Okay. So we have assigned it 0 with the value arbitrarily assigned it voltage as 0 volt. Now we don't have to deal with two variables. Ibrahim, you asked me that what is the need of it? Why can't we measure the electrode potential of simply zinc electrode?
No, so because because the electrode potential of the hydrogen electrode is 0, yeah. So there won't be a potential difference, I think.
Exactly. So
measure it.
if it is 0 is if one is assigned as 0, then whatever the difference that it is easier to get the value of other one. Okay. But I'm asking that if you have just zinc electrode, only zinc electrode, no standard hydrogen electrode. So why can't I measure the electrode potential of simply zinc electrode?
Well, no, because then you'll have to flow a current, yeah, through the electrode.
Exactly. We have to flow the current. If the current doesn't flow, we can't measure the voltage or EMF. Got it? And so we need to connect it to some other electrode. And what is that other electrode? That is standard hydrogen electrode. What is the uh, what is the electrode potential value of standard hydrogen electrode? It
0,
is
we're assuming.
0 volt. How it is constructed? Just can you explain it to me in few words? How to make standard hydrogen electrode? Yeah, Ibrahim, help me out. Just in two,
I don't know.
3 lines, you can say. So, what are the components of standard hydrogen electrode that you need to put them together? So, what are those components? Tell me. Aisha, can you help me out? How to make standard hydrogen electrode?
So we use platinum wire.
Yeah, exactly. We use platinum wire, sealed platinum wire. We dip it in 1 molar HCl solution. And we cover it with a tube and we pass hydrogen gas, we bubble hydrogen gas at 1 bar through this HCl solution. Is it clear? Got it? So this is the construction of standard hydrogen electrode. Electrode potential of all the other electrodes is calculated by connecting it to standard hydrogen electrode. So I hope this is clear to all of you. Okay. What is the purpose of platinum wire? That provides a surface for exchange of electron. Exchange of electron is taking place between what all species? The H plus ions can accept electron. The H plus ion can collide with the platinum wire and that rectangular part which you see at the bottom and get some electrons and change to hydrogen. Or vice versa. Hydrogen can lose the electrons and change to H plus. What is the electrode potential? It is assumed to be 0 volt. So what is the answer to this problem? Tell me. Reduction potential of any half cell, or half cell means any electrode. One side of the electrode is half cell. Is measured using which electrode? Ibrahim, what should be the answer?
Zinc half cell.
No.
No, sorry.
No.
Hydrogen.
Any
Hydrogen
electrode.
half cell.
Any electrode, how it is measured? By connecting that electrode to
Standard hydrogen electrode. Yeah.
standard hydrogen electrode. Right.
Yeah. So we'll have
So which one is a standard hydrogen electrode?
B hydrogen half cell with one more wire.
Why not D?
Sorry, I said D.
D or B? Aisha, Marwa, can you help me out? Jasleen, myself and Ibrahim both are thinking of B and D. So Jasleen, Marwa and Aisha, can you help us out? Which one is the right answer? B or D? Just look at the
So B.
concentration. Which one?
B.
Yes, why B?
Because
Standard hydrogen electrode. Okay. Standard condition. So what should be the
one.
concentration of HCl? Should it be 1 molar or should it be 10 to the power minus 7 molar?
1 molar.
1 molar. So B is the right answer. Got it? Right, Ibrahim?
Yes, sir. B.
This is again the explanation how to Jasleen, you also gave the right answer. Very good. D. And how to use the standard hydrogen electrode to get the electrode potential. So connect it. This is a salt bridge. So if I want to connect, so first look at where the electrons are flowing. And wherever you have electron flowing, that side you will keep on the right hand side. Is it clear? And that will be the cathode. So if you connect with copper, with the ammeter, you can check the flow of electron. So this is cathode, and this is anode. This is standard hydrogen electrode. Cathode copper reduction is happening. So this standard hydrogen electrode can act like anode as well as it can act like a cathode. Jasleen, it will act like an anode if it loses electron. If it is acting like a cathode, it can gain electron. Because it is having both the tendencies equal. So it can act like it is, that's why it is assigned zero value. Both the tendencies are taken as equal, and it can give electron, it can take electron. Depends upon the other metal. And you connect it, so if you connect it with copper, copper is acting as a cathode and this is acting as an anode. So now if you try to measure the EMF of a cell, cathode minus anode, right minus left, and E naught cell that you can measure by with the help of a voltmeter. That is 0.34, this is this, and this is 0. So that's how, this is how it is done experimentally. Got it? This is the experimental setup. I hope all of you understood this.
Yes.
Got it? And this is 0. And EMF is standard EMF. Cathode current flows from cathode to anode. The current flows from cathode to anode. So EMF is taken as a difference of the electrode potential of cathode and anode. Okay. This is measured by putting voltmeter or Wheatstone bridge. In this case, the hydrogen electrode is anode. This is 0. So for copper, it is, the value is 0.34 volt. But there is one more thing which you need to keep in mind. All the concentration should be kept as 1 molar. Why? Because we are measuring standard electrode potential. Because we are measuring the standard electrode potential, so all the concentration must be kept equal to 1 mole. Okay. Who will tell me? What are the drawbacks of standard hydrogen electrode?
Is it like difficult to construct? Because you need a lot
Exactly.
of
Difficult to construct. Yeah, very good. And handling is difficult, right?
yes, sir.
Because every time you have to put this setup and all. Yeah, exactly. This is one drawback. What are the other drawbacks?
Sir, it might be difficult to maintain the pressure and concentration over a long
Exactly.
period of time. And also it might be costly because it's platinum, yeah. So
Exactly, yes. Difficult to keep and maintain the constant pressure of H2 gas as 1 atmosphere. Same in a same way, it is also difficult to keep the concentration of HCl equal to 1 mole. And Jaslyn, there is one more point. The platinum catalyst can get poisoned easily. Is it clear? So that catalyst can get spoiled very quickly.
So we use HCl just for the hydrogen, right?
We use HCl plus.
No, we use HCl just for the hydrogen ions present.
Exactly. You use HCl for H plus ions and H2 gas. So H2 gas can lose electron and get converted to H plus ion. That will happen if the standard hydrogen electrode is losing electron to someone else, like copper or silver, or if the standard hydrogen electrode is getting electrons from any other electrode. So under that condition, H plus ions will accept those electrons from the platinum surface and get converted to H2. So both can happen. It depends upon the other electrode which we are measuring. So it is also difficult to maintain the pressure of 1 atmosphere every time, maintain the concentration of H plus ion to be 1 molar every time. And the platinum catalyst can easily get spoiled. This is known as poisoning of catalyst. The catalyst platinum is very sensitive. Okay. So standard hydrogen electrode is just used one time to list all the electrode potentials. That electrode potentials are only under standard condition, not at every condition. Once you have that standard electrode potentials of all the electrodes or reactions, you make a list, and that list based on a standard hydrogen electrode is known as electrochemical series. That is given in all the textbooks. All your chemistry textbooks will have that standard electrode potential values. Okay, you can use them. How that table is, how those values are tabulated, that each and every reaction was compared or connected to standard hydrogen electron, and with that it was possible to make a list of all the electrode potentials. So I hope this is clear.
Yes.
Okay. Now, how many types of electrode potentials are there? If we dive deeper into electrode potential, now we have the idea that how to get that electrode potential, that we have. The idea we are having, we can have the electrode potentials, right? By measuring, by connecting the various reactions with the standard hydrogen electrode. That's how you get the standard electrode potentials. If we dive deeper into them, that we have two types of electrode potentials for each and every electron. So Jesslyn, can you help me out? Electrode potential are of two types. For zinc, suppose if I am telling, zinc is for zinc electrode. There are two types of electrode potentials. One is the standard reduction potential, SRP. Another is standard oxidation potential, SOP. Standard reduction potential, these two electrode potential, SRP and SOP, can be there for any ion. Okay, and what do they mean? Standard reduction potential, Marwa, that represent the tendency of an ion to accept electron. Are you getting my point? Tendency to accept
Yes, yes.
electron is measured by standard reduction potential. You can see the reduction happening because zinc was +2, it gains electron and it positively charge is reduced to 0. And if you measure the tendency of zinc by connecting it to standard hydrogen electrode, how this is measured? From the standard hydrogen electrode. Okay. And look at this subscript very carefully. All of the students should listen it very carefully. Look at this subscript very, very carefully. So Ibrahim, can you help me out what this means?
So like there's a zinc plate, and this zinc plate, it will decompose to Zn2 plus ions.
The zinc is getting decomposed to Zn2 plus, or Zn2 plus is decomposed to Zn?
No. Zn2 plus will get deposited. Yeah, Zn2 plus will get
So
deposited on the zinc.
yeah, okay. Very, very, you have to look at it very, very carefully, and there are chances of going wrong. Even for myself, if I don't look at them, because they are written in a very, very small font, okay, as subscript, so they are not very clearly visible. So you need to look at them very carefully. So this is zinc +2. It is getting electrons. It is getting electron. Its positive charges getting neutralized. So this is SRP. Got it? Standard reduction potential. Because we can see that this symbol is representing the reduction of zinc. It is minus 0.76 volt. Jesslyn, is that clear or not? Tell me quickly.
So I didn't understand.
Yeah, Isha, yeah, I'm coming to that. Let me complete this SOP also, and we have a complete picture, and then I can clarify all your doubts. Okay. So zinc can lose electrons. Got it? And change itself to zinc 2 plus. Not only zinc, any other, any element. Or it can happen other way around, right? Like zinc 2 plus can accept 2 electrons and change to zinc. Are you getting a point? Do you agree with this? Two possibilities are there. Aisha, is it clear?
So
So two possibilities are there. What is happening in this possibility? Oxidation or reduction? You can remember, if you forget, oil rig, you know all what oil rig is. Means oxidation is loss of electron and reduction is gain of electron. All of you know oil rig. Okay. Oil rig is basically the platforms which you are having in the sea to extract oil from oil rig. All of us know, right? This is oil rig platform for drilling of crude oil. Okay. So there are two possibilities. So oxidation is oil rig. I told you to remember as a mnemonic. Oil is represent that oxidation is loss of electrons and reduction is gain of electrons. Got it? So
yes,
there are two possibilities. So this is what happened. What is happening here? Is it the oxidation or reduction?
oxidation.
Is it the loss of electron or the gain of electron?
Loss of electron.
Loss of electron. If electrons are lost, positive charge will increase. Oxidation is happening. And the electrode potential for this reaction should be written like this. So initially it was zinc, and Marwar later it turned into zinc 2 plus. Initially it was zinc after loss of electrons. So this is SOP. Standard oxidation potential of zinc. Got it?
Yes, sir.
Suppose if you start with zinc plus 2. Zinc plus 2 can't lose electron, it is already plus 2. So it will gain electron. And reg is the mnemonic for reduction is gain of electron. This is reduction happening. The electrode potential for this same zinc should be written in this way. So initially you are having zinc 2 plus. It is gaining electrons and changing to zinc. This is standard reduction. I am writing the abbreviated form. Standard reduction potential of zinc. So for each element, there are to look at them very carefully look at these substrates. So zinc is losing electron and becoming positive. That is loss oxidation potential. Or the zinc plus 2 is gaining electron and changing to zinc. That is reduction happening, reduction potential. Got it? Is that clear to everyone?
Yes, sir.
Marwa, Jasleen, is it clear? Is it clear to all of you? Very, very important.
Yes, sir.
Okay. So for each element, we can express its tendency to lose electron. This is the tendency to lose electron. And we can express a tendency to gain electrons. You need to look at the subscript very carefully. And that can help you out to understand whether it is gaining electron or losing electron. For a single element, we can have two electrode potentials, which can measure its tendency to gain electron or lose electron. For a particular element, the tendency to gain electron and for the same element tendency to lose electron are equal and opposite. I'm not talking about two different elements, I'm talking about the zinc only. Got it? So zinc is having tendency to lose and gain electrons. So they will have same magnitude but opposite sides. Standard reduction potential and standard oxidation potential will have equal values but opposite signs for a particular element. Suppose if I talk about this is SRP of zinc and this is oxidation SOP of zinc. Okay. And the value is 0.76. Magnitude is 0.76 of both of them, but it is minus 0.76 for reduction potential. And for oxidation potential, it is plus 0.76. For any half cell, the value of standard oxidation potential has sign opposite to that of its value of standard reduction potential. Is it clear or not? Clear to everyone? How they are measured? They are measured with the help of standard hydrogen electrode. As per IUPAC convention, Ibrahim, standard reduction potential is taken as the standard electrode potential. Is that clear to everyone? So now we will talk only about this one. Tendency to accept electrons. That is standard reduction potential, and that is chosen by IUPAC. Is it clear?
Yes, sir.
So we will talk only about the standard reduction potential, but you should be aware that if it is given like this, it is oxidation potential. You can convert it to reduction potential by changing its sign. So electrode potential are of two types. The one which measures the tendency to accept electron, that is standard reduction potential. It is chosen by the IUPAC to be considered as electrode potential, standard electrode potential. We can have standard oxidation potential also, which measure the tendency to lose electrons for the same element, for the same compound. Both will have equal magnitude but opposite side. So standard reduction potential is the standard electrode potential, and we can measure it, by connecting that electrode with standard hydrogen electrode. So this, I hope all these points are clear. You should keep in mind, they are very, very important. Got it? Metals have, most of the metals you can write, have negative SRP values. Look here. You can write this point. Metals have negative standard reduction potential values. Why, Brian, is it like this? Why the metals will have negative standard reduction potential values? What could be the reason?
So because most of them are already have excess electrons. Yeah.
Yeah, they are
So that's why.
electropositive. Yeah, exactly. They are
Yeah, they are
electropositive.
electropositive.
So,
So like it will be harder.
It will be harder.
It will be easier for them to gain electrons.
So it will be easier for electropositive, means they can give electron. They are full of electron. Metal have free electron on their surface. They can lose electron
Oh, okay.
easily.
So they
So,
can
but they
easily
don't want,
so
and
they
they
can.
want to become ions. Okay. But if you want to give them electron back, they will not. They already have a lot of electrons on their surface. So they will not want to accept electron. So that's why this is the negative. So most of the metals have negative SRP values. Because metal want to lose electron, they are electropositive. You can write this point, all of you. Most of the metals, except copper, silver, gold, have a tendency to lose electrons. Is that clear?
So
They are electropositive. Yeah. Most of the metals, except copper, silver, and gold, have negative SRP values. Most of the metals have negative SRP values, except copper, silver, and gold. Because metal ions, because metals are electropositive, and they can lose electron, but they can't gain electrons. That's why they have negative value. Negative means no. Got it? Negative SRP in metal do not. Here you are showing zinc as zinc ion accepting electron. So zinc ion doesn't want electron. It is a metal. It want to lose electron. So most of the metals have negative standard reduction potential values except copper, silver, and gold. Because metals are electropositive, they have a tendency to lose electron, but they do not have tendency to gain electron. So in reduction potential, we are measuring the tendency to accept electron. which is not there. So negative value. So just tell me any clarification, any point which require clarification in this slide. Let's check it. Marwa, Jaslin, let's check it and tell me. Ibrahim, Aisha, tell me quickly. Are all the things clear? Or do you need
Yes, sir. Yes.
anything to be re-explained again? Two types of electrode potential. Okay. I can take one more example for copper. Copper, this is SRP or SOP? Yeah, this equation is representing SRP or SOP. Who is going to help me out?
The reduction.
Yeah, this is reduction happening. This is SRP. And this value is measured by connecting this copper electrode to standard hydrogen electrode, and it comes out to be, look, I have written copper 2 plus and then I have written copper plus 0.34 volt. Got it? That is, this value is only there if you have 1 molar concentration at 298. So this is experimentally measured by linking this copper electrode to standard hydrogen electrode. What is this? If this is SRP,
So when we're adding negative two electrons,
yeah, this
then we
is
get
SOP. SOP. What is the this is SOP? What do you mean by SOP?
standard oxidation.
Oxidation
Potential.
potential mean the copper is changing to copper 2 plus and losing 2 electrons. Oxidation means loss of electrons. Got it?
So
So what is the value of this oxidation potential? What is the value? What value should I write? I have already given you one value, which is written so
So it will
this
be the
is,
same, yeah?
it will
0.39
be
volts.
same in magnitude but opposite in sign.
Opposite in sign. Minus 0.32.
Minus 0.34 volt. Is that clear?
so
Right?
Yes, sir. Yes.
Right. So as per IUPAC convention, which value should be taken by default? if I don't use the word oxidation and reduction, if I simply say, if I forget to mention reduction oxidation, if I say electrode potential of copper, so which value should I consider to be the value for the electrode potential as per IUPAC convention? As per IUPAC convention, which type of electrode potential? Jaslin Marwat, tell me quickly. Yeah. Which electrode potential as per the IUPAC convention? Which electrode potential?
Standard reduction potential.
Yeah, reduction potential. Exactly. IUPAC considered the standard reduction potential to be taken as the standard electrode potential. So this is the value which is taken, which is chosen for the electrode potential for copper. Got it? I hope this is clear, right? And when we but this be careful. These values are only for 1 molar concentration, not for all the concentrations, right? And when you compile all these standard reduction potential, you get a series, and all of you are aware of that series. That is, you must have studied that in class, your junior classes, class 10th also. That is electrochemical series. Got it? Is this clear? So when all the elements are arranged as per decreasing or increasing order of their SRP values, it gives us a series, complete series, and that series is known as electrochemical series. Got it?
Yes.
So we are going to discuss this electrochemical series uses and all, very, very important. This is electrochemical series. So you can see that there are some element like F2 is at the highest value plus 2.8. And as you come down, you are having lesser and lesser positive values. You can see these values, positive values are decreasing, and you can see this one, this value, this is the reference value. So there are some, this is 0, reference value. There are some elements which are positive SRP value above this value. They have a tendency to accept electrons. And there are other elements which have lesser tendency than hydrogen. So they will have negative value. These are negative values. Okay, most of the metals do not want to accept electron, as I said you earlier. So most of the metals have negative SRP values. While non-metals and strong oxidizing agents have positive SRP values. Okay. So let's cover this up on the next turn. This was very important. So all of you understood it and replied very well. That's good. but do keep this everything in mind, okay? And in the next class, we are going to move ahead with the electrochemical series and electrode potentials, standard electrode potential, and then how to measure the electrode potential if you do not have standard condition. That we will be covering in the upcoming